Hello guys, hope you are doing well. Welcome back to a new session. This session we'll be talking about the section 3 of chapter 9, which is all about the alkane, the saturated hydrocarbons. And then in the section 4 we'll be talking about the unsaturated hydrocarbon. Guys, these two sections, the remainder of the chapter 9 will be all about the hydrocarbons. The hydrocarbon, we have got two types of the hydrocarbon as we have drawn the structure. A saturated hydrocarbon, examples for the saturated hydrocarbon are alkane and cycloalkanes. We will be talking about them in section 3, in this section. And then unsaturated are the alkene, alkyne, and the aromatics, an example as a benzene, guys. Let us talk about the saturated hydrocarbon. Simply the saturated, we mean the bonding type of or hybridization of the carbon is in sp3 and the bonding is single bonds. But the unsaturated is sp2 and sp1. The hybridization, double bonds, the triple bond, and then double bond in the ring form. We'll be talking about each of them in detail. Let us talk about the saturated hydrocarbons, guys. The saturated hydrocarbons, as we introduced it, are those hydrocarbons in which the carbon molecule forms 4 single covalent bonds with other atoms. When it forms 4 single covalent bonds, the structure becomes a structure which we call as a saturated hydrocarbons. And a saturated hydrocarbon are stable. We'll be talking in detail in terms of stability. They are more stable than the unsaturated hydrocarbons, guys. The example for the saturated hydrocarbon is alkane and cycloalkane. The alkane is in the form of chain and the cycloalkane is in the form of cyclic or rings, guys. But prior to the to talk about the alkanes, we have to memorize these prefixes, guys. These prefixes are basis for what? For chapter 9 and chapter 10 as well. We name the parents based on these prefixes. Meth refers to 1 carbon, eth to 2 carbon, prop to 3 carbons, but to 4 carbon, pent to 5 carbon, hex to 6 carbon, hepet to 7, octet to 8, non to 9, dec to 10. So the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, till 10 included for us. We are not required to know more than 10, but in chemistry we have more than 10 as well. So the structures of the alkanes are given here, the molecular formula, not structural formula. And some of the structural formulas are given, the condensed structural formula for some of those examples. We'll learn how to recognize whether a molecular compound or a structural formula is alkane or not. But guys, from one alkane to the next one, carbon CH4 to C2H6, C2H6 to C3H8, there is a constant unit which they change by, we call as the homologous series. The homologous series is one in which the adjacent member are different by a constant unit, which is CH2 for the alkane. Have a look here, in between CH4 and C2H6, we have got the difference of CH2. C2H6 to C3H8 is CH2. C3H8 to C4H10 is CH2. C4H10 to C5H12 is CH2. So this we call as what? As the homologous series. They change by a constant unit or a constant molecule, which is 1 carbon two hydrogen. Addition of one carbon to the structure, there should be addition of two hydrogen to the same structure, guys. With the alkanes, we have got cycloalkane, guys. But the cycloalkane, the shapes are cyclic or ring. And as you know, it's impossible to draw a cyclic shape or a ring shape or a closed shape with 1 or 2 pointers. There should be at least 3 pointers to close the shape. So the cycloalkane, they start from 3 carbons and above. So we do not have the cyclomethane and ethane. It starts from the propane, cyclopropane. Okay, the cycloalkane are the saturated alkanes in which bonding arrangement is in the form of ring or cyclic structure. In the form of ring or cyclic structure. The general formula of cycloalkane is CnH2n. The N refers to the number of carbon. For example, if it's C4, what will be the number of the hydrogen? 2 multiplied 4 is 8. If it is C7, what will be the possible number of the hydrogen? 7 multiplied 2, 14, and so on. So the structure and the general formula of the cycloalkane is CnH2n. But for the alkane, guys, for the alkane, it's CnH2n plus 2. CnH2n plus 2 is for alkane. As you can see, from the alkane to the cycloalkane, there are two hydrogens in difference. So every alkane with the same number of the carbon has 2 more hydrogen than the cycloalkane, the corresponding cycloalkane. The structural formula of cycloalkane are often drawn in a simplified form. We draw in a simplified form, in a condensed form. It's understood that there is a carbon atom at each corner and enough hydrogen atoms to complete the 4 bonds to each carbon atom. Always, guys, because in the cyclic or ring shape we do not have free ends as the chain in alkane. Here all of the carbon, if they do not have branches, they bonded with 2 hydrogen. That's why we have 2 less hydrogen than the corresponding alkane. For example, here the carbon with the other, CH2, CH2, CH2. We do not have CH3 because there is no free ends. And this is the condensed form, and then this is the shape, and we call as the cyclopropane. We will learn how to name them in the coming pages. We'll talk about the naming structure. Here we have got 4 carbons, and each carbon CH2, 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 CH2. So it's butane, but with the prefix of cyclo, it becomes cyclobutane. Cyclobutane. Here we have got 5. Pentane is 5, so it becomes cyclopentane. Cyclopentane. With the cyclic and the chain form, usually there will be branches. Which group is they become branch? The alkyl group. How to know the alkyl group is, what are the structure formation of alkyl group? Let us talk about the alkyl group. Alkyl groups are groups of atoms that are formed when the hydrogen atom is removed from the alkane. So here we have got alkanes minus a hydrogen, it becomes alkyl. Alkanes minus a hydrogen becomes alkyl. The suffix of the alkane takes ane suffix. Why? Because it's alkane. But the alkyl ends by YL, so the AN is replaced by YL. We have to know the naming of the alkyl group. For example, guys, CH4 is methane. Remove one hydrogen, it becomes CH3 and it becomes methyl or methyl. C2H6 is ethane. Remove a hydrogen, it becomes C2H5 ethyl. C3H8 is propane. Remove a hydrogen, it becomes C3H7 propyl. Methyl, ethyl, propyl, butyl, pentyl, hexyl, and so on, guys, like that. And what's important to be known about the alkyl group, we'll be talking about the branched chain hydrocarbons, branched chain alkane. It's important to know that the alkane, branched alkane, all of the branches are alkyl groups, can be only alkyl groups, and that's why we have to know how to name the alkyl groups. The IUPAC systematic naming of the alkane and cycloalkane. How to name the alkane and cycloalkane. Guys, as I told you, we have got unbranched chain, or we can say straight chain, and the branched chain alkane. The unbranched chain is a long continuous carbon chain, parent hydrocarbon, with no branches, and name it according to the number of the carbon atom. It's simple, we name according to the prefixes that we learn. If the chain is composed of 3 carbons, we call as the propane, 4 carbons butane, 5 carbon pentane, 6 carbon hexane, and so on. But if it's branched, there is a member of alkyl group like methyl, ethyl, propyl, and so on parent hydrocarbon. You have to name the alkyl group and then name the parent. That will be only the difference between them. Let us talk about how to name the straight chain, guys. Straight chain. For a straight chain, as you can see here, we do not have branches. When you draw a line, there is no sub branches from that line. So how many carbons do we have? 1, 2, 3, 4. All the bonds are single and it's in chain form. So this is alkane. Alkane. Alkane with 4 carbon takes a prefix of but. And a suffix of alkane always takes a suffix of ane. So it's simply butane. It's what? Butane. Let us talk about more examples. Guys, as you can see, when you draw a line, it's straight chain, and then the number of the carbons are 6 carbons. We do not have branches. For 6 carbon, we use the hex, and it's alkane, prefix of hex, suffix of ame, hexane, butane. Over here we have got 8 carbons. 8 carbons. For the 8 carbon, we use the prefix of oct and the suffix of ane. It becomes octane, and so on. So for the straight chain, it's very simple. We just use the prefix, depends on the number of the carbon in the chain, and then the suffix of ane. But let us talk about the branches. How to name the branch? We have according to the IUPAC system, which is the International Union of Pure Applied Chemistry. This is the system that we follow in our curriculum for naming the hydrocarbons. For the branched, guys, it's somehow different than the straight, because here we have got branches. We have to position the number of the branches and then name the branches and then name the parent as well. So first of all, find the longest continuous chain. Longest continuous chain. You have to determine it. We call the longest continuous chain as a parent hydrocarbon, or a parent chain of carbons. And the longest continuous chain that have a straight chain branches. we will provide examples. Sometimes you take or select the longest continuous chain, but that longest continuous chain is incorrect selection because of having a branched branch, not a straight branches. And then as we select the longest continuous chain, the number of the carbon atom in the hydrocarbon, so we have to position the numbers as the alkyl group have the lowest position number. We have to number the hydrocarbons from the end that the alkyl group get the lowest position number. And then insert position number and put hyphen between number and name. We will put hyphen between number and name, and between number and number if there will be more than one branch, comma between number and number, hyphen between number and the name is. Let me show you how to name this structure, guys. This is, here we have a continuous chain of 4 carbons. As you can see from this 4 carbon, we have got an alkyl group which is methyl CH3. How to name this? We selected the longest chain, and then we have to provide the numbers to the carbons. From this end, the second has branch. From this end, the third has branch. We have to position the carbons based on the branches to get lowest position number. So we start from the left toward the right, 1, 2, 3, 4, because here the branch gets the 2, the position of the branch becomes 2. And then for the naming, we follow this: number of branch, always, hyphen, name of branch, and then name of parent. Always this is a strategy: name of the branch, number of the branch, name of the branch, name of the parent for the branched alkanes. Number of the branch is what? 2. Name of the branch is methyl. We learn it in the alkyl group. And name of the parent is butane. So the 2 location of the alkyl group, the methyl name of the alkyl group, the but is the number of the carbon. As a prefix we have but for 4, and the ine means this saturated alkane hydrocarbon. Let us name more structures, guys. Have a look on this structure. Here, as you can see, we can let us take the possible selections. 1, 2, 3. No, it's not. 1, 2, 3, 4. 1, 2, 3, 4. So you can take this or that. There is no problem. It's based on you. Okay, guys. Let us take this as the longest continuous chain, and then from this end, the second is branch. From that end, the second is branch. In this case, it's up to you from which end you position the numbers of the carbon. 1, 2, 3, 4, or 1, 2, 3, 4 has the same names. And then on the second, we have got the methyl, the third a methyl. Guys, if there will be the same alkyl group, two alkyl group the same, we add a prefix of di to the name of the alkyl group. 3 tri, 4 tetra. We have only got till 4 branches, no more than 4 same alkyl group usually, but there is existence. So in this case, write 2 comma 3 hyphen. 2 alkyl group, they are the same, so do not forget to use di, and then the name of the alkyl group is methyl, and then the parent is butane. 2,3 dimethyl butane. As I told you, that if there is more than one branch of the same alkyl group present, for 2 di, 3 tri, 4 tetra must be added to the name of the alkyl group, and this is 2,3-dimethyl butane as the name of that structure. Let us solve the sample problem, guys. The sample problem. Here it's given the sample problem. This is the longest chain. From this end, we have got a branch. The second one is the branch, second carbon. From that end, the second carbon is branch. But after the second, in this ending, we have got another branch. But from that end, we do not have got another branch. So guys, in these cases, coming two branches next to each is priority, takes the priority over the one branch alone. Despite of the first is from here, the first branch is 2, from there the first branch is 2, but after the 2 here, we have got another branch directly, but we do not have got another branch from there, so you have to start from this ending in order to have the lowest possible position for the branches. So we name from the right, or number from the right to the left, not the left to the right, because of coming two branches together here, the one branch alone. So on the second, third, and fifth, we have got 3-methyl, 2, 3, 5. For 3, we use trimethyl. The parent is hexane. The parent is hexane. Number of the branches, name of the branch, name of the parent is the systematic naming of the branched alkanes, as we have written the name. Guys, let us solve more questions. Sometime from both ends there will be the same position of branches, but one branch is ethyl, the other is methyl. One is propyl, the other is butyl, for example. In this case, we follow the priority goes to the alphabetical order. The priority goes to the alphabetical order, and alphabetical order are following this. If butyl, the first, ethyl, methyl, propyl. It depends on the ABC in English, A, B, C, D, E, F, G, till the end, guys. Have a look on this, guys. This is the longest continuous chain. This is the parent. And then how many alkyl groups or branches do we have? 2 branches. From this end, 1, 2, 3 is what? Is the branch. From that end, 1, 2, 3 is the branch. Okay. The position of the branch from each end is the same. In this case, we have to follow the alphabetical order. This is ethyl. That is methyl. E is before the M. So you have to position the carbons. The ethyl gets a lower number than the methyl. That's why we have positioned it from the left toward the right, not the right toward the left. To get the third goes to the ethyl and the fourth for the methyl. And in naming the different groups, alkyl groups, always you have to follow the alphabetical order. You have to name the ethyl first and then methyl. If there will be butyl, butyl first, ethyl, methyl, and propyl. That will be the order of the naming. So on the third one, what do we have? An ethyl. Write down 3 ethyl. On the fourth one, what do we have? Methyl. 4 methyl. They are different. We cannot write down 3, 4 together. Okay, guys? This is the alkyl group are differ from each other. We cannot use di-tri-tetra. We use di-tri-tetra when they are the same alkyl group. And then the parent is hexane. So it's 3 ethyl, 4 methyl, hexane. Let us solve more questions, more practice. This is one of the practice that sometimes the students, they may choose incorrectly the selection. We said the selection must be chosen that there should be straight chains, straight alkyl groups, or straight branches, guys. If you may notice, guys, this selection is 8 carbons, 8 carbon. Okay, if we select this as a parent, we have got CS3, and this structure as the branch. Guys, as you can see, notice that this branch has another branch. It's not straight. The branch has another branch. It's not straight. So whenever you select a parent that a branch remain is not straight, that selection is incorrect. You have to select another selection even if the selection has fewer carbons than the incorrect selection. It's not straight chain branches, so incorrect selection. Let us choose the correct selection, and which one becomes the correct selection? This is the correct selection, guys. Here we have got 7 or 8 carbons, and then the CS3, CS2, CS3, CS3, CS3 become the alkyl groups. As you can see, all they are straight alkyl groups. We do not have a branched branch of alkyl group. From which end to position? From this end, the second is alkyl group. From that end, the fourth is alkyl group. So for sure, we have to start from this end to get the lowest possible number of the alkyl group. So 1, 2, 3, 4, 5, 6, 7, 8. That's the parent. How to name? Where to name? We have to name the ethyl and then the methyls. So on the third we have an ethyl. So write down 3 ethyl. Second, fourth, and fifth we have got 3 methyl. You have to use tri. So 2, 4, 5 trimethyl. 2, 4, 5 tri refers to the same alkyl group 3 times repeated. And then the name of the parent, which is 8 carbon, octane, which is 8 carbon, octane, guys. If there will be a question that the name is given, possible in ministerial exam it appears, how to draw the structure. When a name is given, guys, when a name is given, I'll be solving here to you. The name is given. You have to start from the parent and then the alkyl group and then the position of the alkyl group. What's the parent here? Nonane. Nonane has got 9 carbons. 9 carbon. 4, 5, 6, 7, 8, 9. Nonane is 9 carbons. And the numbering, it depends on you. From which end you number the carbons? 4, 5, 6, 7, 8, 9. And then next step is to write the alkyl groups. On the second and the fifth we have got methyl. Second CS3, fifth CS3. And on the third 3, 3, 3 twice repeated. That means there should be 2 groups. We have got ethyl, 2 ethyl, CS2, CS3, CS2, CS3. This is ethyl. Or we can write sometime as C2H5, has no problem. And this is 3 hydrogen, 2 hydrogen, 2 hydrogen, 2 hydrogen, 1 hydrogen, 2 hydrogen, no hydrogen, 1 hydrogen, 3 hydrogen. That's the structure of what? Of 3,3 diethyl 2,5 dimethyl nonane. Converting the name to the structure, follow it. We have to start from the name and then the alkyl groups with their position as well. As you can see, here is the expanded structure is represented, guys. The expanded structure is represented. More questions, guys. Here we have got the longest hydrocarbon. Okay, the longest chain. The longest chain, from this end, the second is branch. From that end, the third is the branch. So you have to number from right to left. 1, 2, 3, 4, 5, 6. Okay. The third, we have got an ethyl. So 3 ethyl must be written first. On the second and the fourth, 2-methyl, dimethyl. 2, 4, dimethyl, and the parent is hexane. To find molecular formula, guys. The molecular formula may be asked in the exam. We have got the general formula for all of the alkane. If it's single bond, the alkane, guys, the alkane saturated, the structure is C2H2N, CnH2n plus 2, CnH2n plus 2, and the N is the number of the carbon. For the alkene, we'll be talking in section 4. Double bonds are what? C2H2n. For the alkyne, triple bond is C2H2n minus 2. For this 2 is for only one double bond and one triple bond. For more double bond and more triple bond, it's valid according to the double bond and the triple bond. Every inserting every double bond removes 2 hydrogen in the structure, and for inserting one triple bond removes 4 hydrogen in the structure. For the cycloalkane, which is saturated, it's what? CnH2n. You may ask why CnH2n and CnH2n here, the alkene double bond and cycloalkane, they have the same structure. Guys, they have the same structure, that's true. But we can differentiate between them by two ways. The first, by naming. Naming of alkene, it's the ends with the ene, and we name according to these chains. But the naming of the cycloalkane, it has a prefix of cyclo, cyclopropane, cyclohexane, cyclobutane. This is the naming. Second, the structure. The structure of the alkene, it's written in a chain form and has double bond. But the structure of the cycloalkane is in cyclic form and single bonds. That's the difference between the cycloalkane and alkenes. Have a look on this structure, guys. Here we have got a structure. It's alkane. Why? Because there is no double and triple bonds. Just count the carbons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if it's C10, it's CnH2n plus 2. 2 multiplied 10, 20 plus 2, 22. So you can get the molecular formula as easy as possible. More examples, guys, the same. Here we have got a saturated hydrocarbon, which is alkane. Just count the number of the carbon: 4, 5, 6, 7, 8. C8, 8 multiplied 2 is 16, plus 2 is 18. So C8H18 is the molecular formula for that compound. If it is cyclo, guys, for the cyclo. In cyclo, sometimes may not write the carbons. Guys, keep in mind, always in every angle of the cyclic and the rings, there should be a carbon. So this angle, a carbon, 2, 3, 4, 5, 6, 8, 9. So it's what? C6, 7, 8. 8, C8, H, it's 2N. 2 multiplied 8 is 16. So you get the C8H16 as the number of the carbon and hydrogen, the molecular formula for that structure, guys. Let us talk about the naming. We talked about the naming of the alkane. Let us talk about the nomenclature of the cycloalkane. The cycloalkane has the same systematic naming of the alkane, but with the prefix of the cyclo to the parent. Instead of writing butane, we have to write cyclobutane, pentane, cyclopentane, hexane, cyclohexane, and so on. Let us talk about some of the tips. First of all, count the number of the atoms in the ring. We have to count the number of the atoms in the ring, and here the ring becomes the parent. So the ring is the parent always. Write cyclo at the prefix corresponding to the number of the atoms as the ANA. It's alkane. We just write the cyclo as a prefix to the name of the parent. Add the name of the alkyl group in front of the name of the parent hydrocarbon in alphabetical order. As we said, in alphabetical order, we have to name the alkyl groups. When there is more than one branch of the alkyl group, attach the appropriate numerical prefix to the name. More than one branch, tetra, here also included, for more than one branch of the same alkyl group. Number the carbon atom in the parent hydrocarbon according to the lowest position, or goes for the alkyl group. The alkyl group, they must have the lowest position. And then insert the position number and punctuate the names and then name the compound. But we have an important note here. An important note here. The note said, give number 1 to the alkyl group according to alphabetical order, then choose direction with lowest position number. Always for the first number we have to follow, or the priority goes to the alphabetical order. When there is methyl, ethyl, propyl, you have to start from the ethyl always in the alphabetical order. Let us name some of the structures for the cycloalkane, guys. As I told you, in every corner, in every angle, there should be a carbon. Don't forget that. And then if it's not branched, attach it to 2 hydrogen. If it's branched, to 1 hydrogen. 2, 2, 2, 1. Why? Because this carbon bonded with the 3 bonding with the other carbons. How many hydrogen remain to be 4? 1. But that carbon bonds to 2 hydrogen remains. That's why if there is no branches on the carbon, the carbon must be attached to 2 hydrogen. If there will be a 1 branch, to 1 hydrogen. If 2 branches on the same, no hydrogens will be attached. So how to name that structure, guys? First of all, you have to number according to lowest position of the, here we have got 2 branches of methyl. So the methyl, they are both the same alphabetical. Start from this. If we start from this, you have to rotate the counterclockwise, because the next one to get the lowest position number. But if you start from the above 1, you have to rotate the clockwise, in clockwise direction, because in clockwise the next one, the next branch will be 3, but in counterclockwise direction it will be 4, the next branch. So you have to choose the direction, or you have to rotate in a direction that the branches, they have the lowest position. In this case, 1, 2, 3. So on the first and the third, we have 2 methyl. So write down 1, 2, 1, 3, sorry, dimethyl. Di refers to the same alkyl group, and then cyclohexane. It's hexane, 6 carbon in the ring, but we add the prefix of cyclo. Here we have got 1 carbon, 2, 3, 4. It's cyclobutane, the parent, but on the first we have got 2 branches methyl. When we have got the same 2 branches on the same carbon, you have to repeat the number of that carbon twice. So here we have repeated 1, 1, dimethyl cyclobutane. The systematic naming is the same as the alkane, but we add only cyclo to the prefix of the parent. Number of the alkyl group, name of the alkyl group, and then name of the parent with the cyclo. Have a look on this example, guys. This example, we have got CH2CH3, which is ethyl, and CH3, which is methyl. From which one we have to start? From the alphabetical order, the one that's priority in alphabetical. So E is prior over the M. We have to start from the E. One must be on the ethyl group. And then in which direction we should rotate? Count in the clockwise direction. Why? Because the third will be the branch. But in counterclockwise, the fourth will be the branch. So 1, 2, 3, 4, 5, 6. It's what? The 1 ethyl, 3 methyl cyclohexane. 1 ethyl, 3 methyl cyclohexane. The other branch we have got, this is ethyl, methyl, and then methyl. From which one we have to start? Always the alphabetical order. So first goes to the what? To the ethyl. In this direction, the third is branch. In that direction, the second is branch. So you have to rotate in a counterclockwise direction, because here the branch comes closer to the other branch than that. Okay, on the first we have an ethyl, so write down 1 ethyl. Second and the fourth, 2 methyl. Write down 2 fourth dimethyl, and then the number of the parent is pentane, cyclopentane. You should write as the number of the parent, guys. Write the name for this formula. Let us practice some more questions. Here we have got 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. Always, guys, the parent is not straight. Can be L-shaped or any other shaped. So you have to choose the longest chain. As you can see here, the longest parent is this shape, which contains 7 carbon. But if you choose the straight one, it is 6 carbons. And then let us position the numbering. From this end, the third is the branch. From that end, the fourth is branch. So you have to start from this end. 1, 2, 3, 4, 5, 6, 7. We have got 2 branches on the third and the fourth. So write down 3, 4 dimethyl. 7 is what? Heptane. It's what? It's alkane. Let us name other example, guys. Here, 1, 2, 3, 4, 5. 1, 2, 3, 4. Guys, this is an example to show you that sometimes maybe condensed the structure. If it's condensed, it's not written as CS2, CS3, CS2, CS2, CS3. You have to notice about that. Sometimes when we open it, it becomes the parent instead of being a what? Being a alkyl group. So it's what? CH2, CH3. Okay? In some cases, can be longer, and in this example, it's not true because we have unstraight chain. But some other example, you have to notice always to open the alkyl groups that have written as alkyl group. Maybe it becomes a parent. So the longest parent is this, guys, and then the longest chain. Then we have got 3 alkyl groups. From this end, the second. From that end, the third. So you have to start from this end. 1, 2, 3, 4, 5. On the third, what do we have? 1 ethyl, one ethyl, so I mean 3 for the position, and then on the second and the third dimethyl pentane. The parent is 5, which is pentane. Let us name this structure. As we solve more example, you will see more options and more solving. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7 is not. So the 8 is the longest continuous chain. Okay, this becomes they are what? The alkyl groups. Okay, from this end, the second is branch. From that end, the second is branch. From this end is followed by another branch. From that end is not followed by another branch. So you have to start from this end. 1, 2, 3, 4, 5, 6, 7, 8. On the fifth, what do we have? Ethyl, 5 ethyl, 2, 3, 7 trimethyl, what? Octane. That's the name of that structure. Okay, this is cyclo, guys, cyclo. We have to start from the ethyl and then methyl. 1, 2, 3, 4, 5, 6. The name is what? 1 ethyl, 2 methyl, cyclohexane. Cyclohexane because it is cyclic. Let us solve 2 more examples. 1, 2 more example, and then draw the structure. Let us draw the structure for this. It's pentane, that means 5 carbons. 5 carbons. 1, 2, 3, 4, 5. And then on the third we have got 2 methyl, CS3, CS3. And then that's the structure. You have to insert the carbon, the hydrogen, 3, 2, 2, 3. That's the structure. Cyclopropane. Cyclopropane is cyclic form. Okay, propane is 3, 1, 2, 3. Okay. On the first 1, 2, 3. On the first, what do we have? The dimethyl. So 2 methyl on the first, CS3, CS3. This is 1, 1 dimethyl cyclopropane. More questions. Let me solve. Pentane, it is 5. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. On the second, what do we have? Methyl. On the fourth, 2 methyl. CS3, 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 CS3. That's how we can draw the names, structure for those names, guys. Let us talk about the properties and uses of the alkane. Guys, the usage of the alkane are composed of hydrocarbon. The hydrocarbon are non-polar. So the first thing is what we have to know. Carbon-hydrogen bonds are what? Are non-polar. So non-polar molecules are not able to dissolve in polar like water. They are not soluble in water. The forces between the non-polar molecules, the atoms of the non-polar molecule is what? Is a weak London dispersion force. The weak London dispersion force exists between the molecules. What's the London dispersion force? The London dispersion force, we talked in graphite, is a weak force existed between the atoms of the hydrocarbons, and this becomes stronger when the molecular size becomes more. So guys, if there will be such question, C2H6 C5H12, C8H18. Which one has more London dispersion force? The one that has more molecular size. So the London dispersion force increase as the molecular size increase. Why? Because as there will be more hydrocarbon, there will be more attraction between them. More attraction, that means more London dispersion force between them, guys. Let us talk about the physical states of the alkanes. Alkane, they exist in three physical states: gases, liquids, and solids. The lower alkanes of C1 till C4, they are all gases. So the alkanes have the lowest masses, with the lowest masses of the C1 till C4 are gases. These gases we call as the natural gases, which we obtain from the production of the petroleums in the refineries, in the oil wells. So the natural gas is what? Is a fossil fuel composed of the alkanes of carbon 1 till carbon 4, CH4, C2H6, C3H8, and C4H10 are all the natural gases: methane, ethane, propane, butane. Propane, butane is the gas, the liquefied petroleum gas, LPG, which we use for cooking in our kitchens. And then, guys, as the hydrocarbon increase, the state also changes. The carbon 5 up to carbon 10, in chemistry up to carbon almost 18, 17, 18 are all liquids. Liquids like gasoline, naphtha, kerosene, diesel, and so many other products. So examples of the liquid alkanes are the gasoline, kerosene, naphtha, and diesel. Alkanes that have a very high molecular mass, such as paraffin wax, are solid. So as the molecular mass increase, number of the hydrocarbon increase in the structure, it approaches toward the solid. As it becomes lower, it becomes a liquid. And there should be such examples, guys: CH4, C15H32, C4H10, or for example, 30H62. Which one is the most, has most possibility to be solid? Of course, the one with the higher molecular mass. Which one is gas? These two are gases, and this almost in the range of the semi-solids. It's liquid and solids. So the paraffin wax used in the candle, guys, and is a solid which has the molecular molecular mass of the between C2060 till C30. Greater the mass, greater London force and closer molecules held together. As I told you, as the molecular mass increase, that increases the London dispersion force. As London dispersion force, the molecule from gaseous goes to liquid and then to solid. Let us talk about the physical property of boiling point. Boiling point, guys, of the hydrocarbons changes with the London dispersion force and with the molecular mass as well. So the boiling point of the alkane increase with molecular mass. The one that has a higher molecular mass has higher attractions, higher or stronger London dispersion force, more London dispersion force. More London dispersion force needs more heat to be provided and to boil. So as London dispersion force increase, more energy is required to pull the molecule apart and boil them. This property is used in the separation of petroleum, a major source of the alkane. Guys, in the refineries, from the petroleum wells, when we produce the petroleum, we call as the crude oil. The crude oil is a complex structure, has no application, but in order to use it for several products, we have to separate it into different components. How to separate the petroleum into the different components? Based on their boiling point. In refinery, there is a distillation tower. The distillation tower, in every trace, it's ranked on the trace, tray by tray. In every tray, one product goes outside. In every trace, the product, different products going outside, and then based on their boiling point. So as I told you, petroleum is what? Is a complex mixture of different hydrocarbons that varies greatly in composition. They change in composition starting from carbon 1 up to carbon 75. They are all the composition of the petroleum. Guys, so we can say London dispersion force increase or molecular mass increase, molecular mass increase, that increase London dispersion force. And as London dispersion force increase, the boiling point of the structure increases too. But if we have more branches or straight, what to say? Guys, if there will be a branches, the branch has lower boiling point than the straight alkane with the same hydrocarbon. So as the number of the branches increase, boiling point decrease. Why? Because surface area of the molecule decrease and London dispersion force decrease. Have a look on this, guys. Here we have got two branches, has got almost 10 Celsius the boiling point, but one branch 27. As the number of the branch decrease, the boiling point increase. So the branched chain has lower boiling point than the straight chain, guys. This is true for what? This is true for the same molecular mass. Usually the boiling point of a straight chain is higher than the branched chain. Why? Because a straight chain has more surface area, and thus it becomes branched. The surface area of the molecule decrease, and then that decreases the London dispersion force, and then the boiling point decrease as well. Combustion of the hydrocarbons, it's eliminated in the Kurdish version, but I prefer to talk about the combustion. Guys, the alkanes, they composed of the hydrocarbon, and as the hydrocarbon combust with the oxygen, they will produce CO2, H2O, and release energy in the product. So the combustion of the hydrocarbons, any alkane, produce CO2, H2O, and release energy to the medium or to the system. Let us talk about the octane rating and the knocking of the fuel. Guys, we may have observed knocking in the engines, usually the gasoline engines, due to of low quality or low octane number of the fuel. That in chemistry we call as the knocking. So the knocking is what? Is the disturbance of engine by incomplete burn of gasoline fuel because of presence of straight chain hydrocarbon. So what's the result, or what's the reason behind of knocking? The reason is having a straight chain hydrocarbon, or the straight chain hydrocarbon, they do not combust completely, and as they do not combust completely, there will be knocking in the engine of the cars. So therefore there must be an anti-knock gasoline fuel such as isooctane, which is a branched alkane, which consists of a branched hydrocarbon that ignites spontaneously. In order to solve this problem, we have to increase the octane number. The octane number can be increased by what? By addition of the branched hydrocarbons to the fuel, such as isooctane, which has 100 octane number. The isooctane is 100 octane number, and this is maximum octane number that we have. As the octane number increase, the fuel become more efficient in combustion, and it combusted with the high efficiency. There will not be knocking in the engine of the diesel or gasoline fuels, in the gasoline fuels. So the isooctane, which has a name of 2,2,4-trimethylpentane. Here is what? 1, 2, 3, 4, 5. This is the isooctane, guys. 2,2,4-trimethylpentane is what is isooctane, which burns slowly and efficiently, unlike the heptane, which has a 0 octane number. So the heptane is 0 octane number and burns rapidly and inefficiently, uncontrolled in burning. So it's completely unfavored hydrocarbon to be added for the engines. It increases the knocking. The isooctane decreases the knocking. The heptane has a 0 octane number, the isooctane 100 octane number. The heptane burns rapidly, the isooctane burns slowly and efficiently. This is inefficient, and it increases or decreases the octane number. What's the octane rating? Octane rating of a fuel measures the burning efficiency and its anti-knock properties. We have got octane number or octane rating. Octane number can be represented by two scales, RON, we call as RON, or MON. These are two methods or two procedures, two scales to measure the number of the octane in the fuel, and as it becomes more, the fuel becomes efficient and slowly combusted, and then there will be elimination in the knocking of the engine in the gasoline fuels, guys. That's the end of the session. Thank you for the attention. We will be talking about the section 4 in the coming